BSc 2022 and 2023 for for this session. Okay, and there is no deletion from the first chapter. Okay, and I have told you about the equilibrium. So simply, you should remember that when a charge is in equilibrium means the net force on that charge is zero. And I will use these concepts in the upcoming questions. Okay, so hmm. So one thing I want to tell you, like there is a point here is a charge Q1 and here is a charge Q2, and suppose they both are of positive charge. Okay, and so due to this charge will experience some force. Okay, and this force, the direction of this force is like this, and I will give the name of this force. Okay, I will give the name of this force. I will represent this force F on charge 2 due to 1. And due to this charge, the direction of force is like this, and I am representing this force F on charge 1 V due to the charge 2. And the magnitude of both these forces are equal. So I am writing this point because I will use this in the numericals. Force due to you can write like force on charge 1 on charge 1. Okay, force on charge 1 due to charge 2. Force on charge 1 due to charge 2. I am highlighting this on charge 1 just, and F21 is written as force on charge 2. This is here, first term is 2 due to charge 1. Do not get confused in that. So we will solve this numerical. After that, this numerical. You can see these kinds of numericals in your examination, board examination also. Is my voice clear?
Yes, sir.
Okay, fine. So this is a question, and three equally charged small objects. Uh, Small objects, and they are equally charged. are placed as shown in figure. Means here an object is placed, and here and here at point A, B, and C. The object A, this is the object A. Here is the small objects, and those small objects having some charge. So we can say these are the point charges. Okay, means these are point charges. Like you can say this is the small object and this object have charge, like we have discussed. So the object A, means this object, exerts an electric force on object B, on object B, and this force is given by its value. So what I am doing here, I am representing this. This is fine. So this is the force this object exert on this, and they are equally charged, means they have same charge. They have same charge. So the direction of force due to A on B is in this direction. And how can I represent this force? Force on B due to A. Fine. This is the
Yes, sir.
force. This is the force on B due to A. And this value is given to us. 3.0 means 3 into 10 to the power minus 6 Newton. And the distances are also given. First part is, what electric force does C exerts on B? C exerts on B. So this here is a charge. You can imagine here charges are placed. You can imagine. And due to this charge, the force on B will be in this direction because they are of same because they are same charges. So I will represent this force on charge B due to charge C, and this is we have to find force on charge B due to charge C. This is we have to find, and for that we have to do some calculations. This is fine. So for the first part, we have given this FBA equal to 3 into 10 to the power minus 6. So if I want to calculate FBA, I have already told you there is some another approach to solve the numericals. Numerical means analytical thinking, means breaking down the problems in parts. Okay. So here I want to calculate FBA. What is the value of FBA from here? If here is a charge Q, if here is a charge Q, then FBA can be written as K Q1 into Q2 and divided by the distance, square of distance between them. So I am writing
Yes.
here K Q1 and Q2 means Q square and divided by what is the distance? Distance is given in centimeter. And 1 centimeter is like, okay, this is the square. 1 centimeter equal to 10 to the power minus 2 meter. Actually, we are using all the quantities in SI unit. So, and this value is given. This value is given. This value is given as 3 into 10 to the power minus 6. So now we have this. So what I am going to do, I will put the value of k 9 into 10 to the power 9 and into q square, and I can multiply this with this now. So the square of this will become 4 into 10 to the power minus 4, and if I multiply this, this will become 3 into 10 to the power minus 6. And I am calculating q square from here. So this will become 4 3s are 12 into 10 to the power minus 6. And this is divided by 9 into 10 to the power 9. 9 into 10 to the power 9. So from here, I can cancel this with 3. So this will be 3 4s are 12 and 3 3s are 9 into 10 to the power. This will become, this, the power will be add. This will become 10 to the power minus 6 and minus 9. This will be minus 15. 10 to the power minus 15. The value of q square. I have calculated q square. 4 by 3 into 10 to the power minus 15. This is the value of q square. And I want to calculate the FBC. We have to calculate FBC. F, force on V due to C. So see here, V and C. There are two equal charges and which are separated by 1 centimeter. So K q square divided by 1 into 10 to the power minus 2 square. And actually we should calculate the value of k q square directly, but no problem. So we have the value of k now, 9 into 10 to the power 9, and we also have the value of q square. Q square is 4 by 3 into 10 to the power minus 15. And again we are having this. This will be 10 to the power minus. So we can solve this. This 3, this is cancel out, and this will become 4 3s are 12. 4 3s are 12 into 10 to the power 9. This will become 10 to the power minus 6. Okay. Do you know these types of calculations, power calculations?
Yes, sir.
Fine now? Is it fine?
Yes, sir.
Oh, okay. Very good. So this will become 10 to the power minus 4. So after that, we will get 12 into 10 to the power minus, oh, sorry, 1 minute, minus 6. This is 10 to the power minus 4. So this will become 10 to the power minus 2 Newton. Okay,
Yes, sir.
so this is the force FBC. We have the answer. Now we have to calculate the net electric force on B. Net electric force on B. So see here. Here is a point B, and in this direction we have a force FPA, and in this direction we have FBC. Okay, fine now. So we have this, and if and uh, this is the charge at B. Q charge is placed at B, and if I want to calculate the net force on charge at B, what will be the value? We can subtract. We can subtract. Okay, these are two anti-parallel vectors. These are two anti-parallel vectors, and for calculating the net force from this, we simply subtract two forces. So I am subtracting F BC minus F BA. F BC, we have 12 into 10 to the power minus 2, and we have FBA. FBA is 3 into 10 to the power minus 6. 3 into 10 to the power minus 6. Okay, so this is our final answer. This is our final answer. Net force on B. Have you understood?
Yes, sir.
So you can say this is little bit tough question. Okay. So what I have done, first I have calculated this, and I got the value q of q square 4 by 3, and I have put 4 by 3 in 10 to the minus 15. It will be 10 to the minus 6, and here we have 10 to the power minus 4, and this 4 will come up. Okay, and we got this, and we can calculate this value also. Okay, no problem. So should I move?
Yes, sir.
So
Yes, sir.
actually, I have lost my internet connection. So I have connected with my phone. So maybe you will get some problem in my with my voice. Okay.
It's fine, sir. You're audible.
Okay. And if you have any problem, then please tell me.
No, sir.
Actually, with a phone now, there is slow speed when we connect the laptop with phone's hotspot. So this is our question, and our next question is, this is our next question. So now we will solve this question. So here you can see, is my voice is clear now?
Yes, sir.
Actually, this is very important question. Please see this carefully. There are two identical charges Q each are kept at a separation R from each other. So first what we do, there are two charges and this is the line joining between two charges, charge Q, and the distance between the two charges is R. No problem. They are saying a third charge Q is placed on the line joining the above two charges such that all three charges are in equilibrium. All three charges. See here. And earlier we have solved a question. In that question, there is the equilibrium of only one charge. But this time we have to ensure the equilibrium of all the three charges. So we have to think little bit. We know the distances are in between. We have to think little bit. And they are asking what is the magnitude, sign and position of charge. Magnitude, sign and position of charge. So we should first choose the charge. Charge can be of two types. They are saying what is the uh, sign, position. What is the sign? The, the sign of the charge, either the charge can be positive charge, either the charge can be negative charge. Okay, so you have to decide, you have to choose one charge at a time. Like we have uh, we have done in combination and permutation and combination, we have to choose there one thing at a time. So we will choose one charge at a time. So this is on your wish. Suppose I am choosing a charge plus Q and I am putting somewhere here, I don't know the location, means I am putting this charge in between these two charges. This is the point. This is plus Q charge. And now we will see after putting this charge here, all the three charges are in equilibrium or not. So there is a method. We have already discussed that method. Nothing special in that. You can see you should choose the charge. Okay, first you should choose the charge. I want to calculate the net force on this charge. Equilibrium means three charges will be in equilibrium. Three charges will be in equilibrium. When can you tell me when three charges will be in equilibrium?
Also should be stable.
Yeah, all charges should be stable. Means net force on this charge, net force on this charge, net force on this charge should be zero. Okay. So I want to calculate the net force. I am supposing this charge as one charge, this is charge 2 and this is charge 3. And now I want to calculate the force on charge 3 due to charge 1. So direction will be, because this is also positive, this is also positive. This charge is positive, this charge is positive. So direction of force on charge 3 due to charge 1, like this. And due to this charge, direction force on charge 3 due to charge 2. So means this charge may be in equilibrium. This charge, there is a chance that this charge can be in equilibrium when F31 is equal to F32. Okay, no problem. Now let's choose this charge. Now let's choose this charge. So I want to calculate the force on this charge 2 due to these both the charges. So if I want to calculate the force due to this charge, so direction of force will be like this. Force on charge 2 due to charge 3, and there is another charge also. Due to this charge, the force on this charge, the direction is same now, will be in this direction. Force on charge 2. So can this charge be in equilibrium? This charge will never be in equilibrium. Never. Why never? Because here two forces are acting in the same direction. Always they are acting in same direction. They cannot this charge cannot be in equilibrium. So here I am writing never be in equilibrium. Same is the case here. If you do this, never be in equilibrium, can be in equilibrium. Why can be in equilibrium? Because if these two forces are equal, this charge is in equilibrium. So this we have done by choosing the first we have choose the positive charge. So means here only one charge can be in equilibrium. The two other charges can never be in equilibrium. So we will not put the positive charge. Okay. So what should I do now? I should place I should place this is Q. Okay. Mm. So earlier we have placed positive charge, and this time I am placing a negative charge, and we will see whether the system means these three charges will be in equilibrium or not. This question again, I am telling this question, this these two questions are very important. That's why I am taking more time, because you will see these kinds of questions in your examination also. So now I am putting a minus q charge, and we will see whether this. So I want to calculate the force on this charge 3. So due to this charge, the force F on 3 due to 1 in this direction, and force on charge 3 due to charge 2 is in this direction, means this can be in equilibrium. Let's see here. Due to this negative charge, the direction of force is in this direction, means force on charge 2 due to charge 3, and due to this charge the direction of force, both the charges will repel each other, means direction will like this. So I can say force on charge 2 due to charge 1. So this can be in equilibrium also, and same is the case with this when you do the same thing. So means when I place the negative charge, so there is a possibility that these all the three charges are in equilibrium. Okay, this is the case. So we have decided that we will put the positive charge, sorry, negative charge. And means the sign of charge is negative. Sign of charge is negative. Now this question is very simple. Here Q was placed, here also Q was placed, and we have decided that we have to place a charge minus Q, and we don't know the location, and we can find that with the help of calculus. Suppose I am putting the minus Q charge here. Okay, I am putting the minus q charge here at a distance of x from this. So this distance will become r minus x, r minus x. So if I want to calculate the force here, so the force here we have represented F32 and F31. This system will be in, this system will be, sorry, this charge will be here. Now we know that all the charges are in equilibrium. So for the equilibrium of charge minus q, for equilibrium of charge minus q, these both the forces should be equal, na? These both the forces should be equal, means net force on this charge is 0. So I can write F31 is equal to F of 32. And we will calculate the value of F31. F31 means this is 1 and this is 2 and this is 3. F31 means between these forces. So what is the formula? K, Q and Q divided by distance means x square, and between 3 to this is Q and this is Q, K Q Q divided by R minus x square, R minus x square. K, these terms cancel out, all the terms are cancel out, and we will get x square is equal to R minus x square, and we will take the under root, then we will get x is equal to r minus x, and this will be 2x is equal to r, and the x, we have to find the x now, x is equal to r divided by 2. This is the final answer. This is the position of charge. This is position of minus q charge. We have find the sign of the charge. Sign of the charge was negative. Sign of the charge was negative. And now we will find the magnitude of charge. So for finding the magnitude of charge, what we will do, this charge is also in equilibrium. Okay, means you can say this charge and this charge and this charge, all three are in equilibrium. Means this charge is also in equilibrium. So let's see. This charge is in equilibrium means F13 is equal to F12. F13 is equal to F12. For equilibrium of charge Q at 1, F13 is equal to, what was that? F13 is equal to F31. F13 is equal to F F13 is equal to F12. Okay, F13 is equal to F12. F13 is equal to F12, and we can calculate F13 K actually I am not using my mouse. F13 F13 will be K Q Q by X square. K Q by X square, and F12 will be F12 1 and 2. K Q into Q, K Q square by R square. K Q square by R square. So from here K and K cancel, Q and this cancel, and we have Q is equal to Q into X square by R square, and we have Q and X is equal to R by 2. I can write X is equal to R by 2 means X square can be written as R square by 4, and here is one another R square and R square cancel. So we will get the magnitude of charge as Q by 4. Okay, we have got the connection back. Is it fine?
Yes, sir.
So this is the whole actually use of all the things that we have studied. Now I am having mouse, so now it's okay. So don't think these things has taken the time, but have you got now clearly?
Yes, sir.
If any question will come in the examination like this, can you solve that?
Yes, sir.
Okay. So as you have joined the late, so now I am having another class. So please note it down.
Yes, sir. I noted down.
Noted now? So why we have not placed the plus Q charge here?
So because it can never be in equilibrium like that with positive, because both will be positive.
Means not the charge Q, means not all the charges cannot be in equilibrium. I am taking time to describe these things because these things are involves the vector addition and all that. So that's why I am taking the time. So okay, that's all for today, and thank you for joining.